So if we want to do a complete example here, let's go ahead and just build a Fibonacci generator on a cell matrix. And we're going to do this in pretty much the most straightforward way possible. We're going to use the shift register circuit that we already designed. And I'm going to use two shift registers. So this will be one, and this will be, say, an 8-bit shift register. And we'll put another one down here. And we will use the fact that these are shift registers to allow us to take the data in this register and send it into this second 8-bit shift register based on the application of a clock. So we'll have a clock going into both of these, and the clock actually goes into the bottom of each stage, but we'll just draw it like this. So here's the clock, and when the clock ticks, the value of this shift register will get loaded into this one. Whatever's coming into the top of this will get loaded into this shift register. So there'll be an 8-bit bus coming in up here. And I'm going to take an 8-bit adder and put that over here. And the circuit is very simple now. We're going to take the output of this shift register, feed that into the bottom of the adder. Take the output of the top shift register, feed that into the top of the adder, and then take the result of the adder and send that out into the top of the shift register. And every time that we tick the clock, the sum of these two numbers should get loaded into here. The previous value of here should get loaded into this, and this value will be lost. So the way this is going to work is as follows. We're going to start off with a 1 and a 0, and that will produce a sum of 1 coming out of the adder. When we tick the clock, this 1 will get loaded down here. This 1 will get loaded into here, which will stay the same, and now the output of the adder will go to 2. The next time we tick the clock, this 1 will get shifted into here, but the 2 will get shifted into this register on the top, and we'll have a 2 and a 1, and the 2 and the 1 will add to give us 3. And the next time we tick the clock, this 2 will shift down here. The 3 will get shifted into the top, and we'll have our 3. So we've been outputting a sequence of 1, 1, 2, 3. And the next time that the clock ticks, the 3, the 2 and the 3 will get added immediately, which will give us a 5. The next time the clock ticks, the 5 will get loaded into here, and the 3 will get loaded into here. So this will become a 3. And this will become a 5. And so the next value coming out is 5, and now 5 and 3 will give us 8. And the next time we tick, the 5 will move down here, the 8 will move into here, and we'll get an output of 8, and so on. So this will be Fibonacci sequence generator. And we'll take the bit values coming out of this adder and send those as our current Fibonacci output F, 8 bits. And that's pretty much all there is to it. So we're going to lay this out using the loader tool and simulate it using the simulator. The one trick on this is that we will need to seed this system, because when we first begin, both of these registers are going to have a value of 0, which means the adder will output a 0, which means each time that we tick the clock, we're just going to be loading zeros back into each register. So we're going to need to seed this somehow. And if we call this register A, what I'm going to do is I'm going to feed this least significant bit A0 is going to be, and it's going to be the following. If A is equal to 0, I'm going to load a 1. Otherwise, I'm just going to load A0. So I'm going to build a little bit of special purpose logic that will perform this calculation. And basically, I'll take all 8 bits of A, and I will OR them with each other and then invert it. So A0 ORed with A1, ORed with A7. Going to invert all of that. And then I'm going to OR that with A0, and that will be the bit that I actually send into here. So now if the value coming out of the adder is all zeros, this will be a 1. It'll get ORed with the least significant bit, and then my A register will be initialized to 1. If anything coming out of the adder is a 1, if the value is non-zero, then one of these will be true, this will be false, and the least significant bit will not change. So we'll build that circuit also to seed this automatically. So when we first load this circuit into the simulator and everything is zeroed out, the first value that we load into this register will be 1. So that will start our sequence at 0, 1, and then it'll be 1, 2, 3, 5, 8, 13, 21, and so on, hopefully. So that's the basic setup. Now, normally you would do some floor planning ahead of time, but this is a simple enough circuit that we can probably just wing it directly, working with a large empty grid inside the loader. We can just place things and move them around, and it'll be good practice in seeing how we manipulate circuits on this platform and how we can move things around, make space, insert things, and so on like that. So let's get going with using the tools and see if we can actually lay this circuit out.